Alright, I'd like to take just a few minutes here to show you how to graph a function by plotting points. In the notes, you'll find this material covered on pages 352 through 353, and I also want to point out that this material is not going to be on the test. The only graphing you're going to see on the test is the stuff that we did at the very beginning. That is about the first 21 or 2 problems where you have graphing of parabolas. That's it. Any other graphing you come across in the assignment is not on the test. Now I want to show you this just because some of you might want to go beyond the parabola to look at other types of functions, higher level functions, such as a cubic function or a hyperbola. And this just gives you an opportunity to explore those higher level functions, though we're not going to go in depth. We're going to be focusing on just plotting some points, keeping it simple. If we had time, we could definitely analyze these functions in more detail, but we're going to defer that to other courses such as college algebra, pre-calc, and even a trig class is going to explore a lot of different functions besides the ones we've been looking at. And they'll go into depth there in those courses. Now, how do you graph a function by plotting points? It ain't hard. Let me show you a quick example here. Let's take an example here of f of x equals whatever I have here, x cubed minus 2. Alright, so there's the given function. And basically to plot points, just like we've been doing since the first assignment, give yourself a little xy table here, let's say. And you want to pick some values of x's, plug them into the function, get some y values there, and plot those points and draw the curve. That's essentially all we're doing. Now, my advice would be try to keep it simple. Keep the values of x, choose these guys so that you're not going to have to work too hard. Usually keep those values small. Otherwise, you're going to have to go way off the xy axis to try to graph those guys. It's going to be a bit of a pain. You can see, for instance, if I try to plug in, say, 5 for x, what's 5 cubed? That's 125. That's way out there. You probably don't want to waste your time with that. It's not necessary. So let's keep the values of x pretty small here, close to 0. There's a couple of values close to 0. Maybe put a couple of negative ones in there as well. Alright. So this should be pretty easy to work with. Now, what are the y values going to be? Well, that's pretty easy to compute. You put a 0 in here for x. 0 cubed is 0. Minus 2 is negative 2, and so forth here. 1 cubed is 1. Minus 2 would be negative 1. 2 cubed is 8. 8 minus 2 is 6. Negative 1 cubed now, that's a negative 1. Minus 2 will be negative 3. And finally, negative 2 cubed is negative 8. Negative 8 minus 2 is negative 10. Alright, so not that hard to do. Keeping it simple. We've got 5 points now that should be pretty easy to plot. We'll go ahead and plot those and then connect the dots, as it were, with a smooth flowing curve. By the way, this is an example of a cubic function. So that's sort of the next level up from a quadratic. The picture that we're going to get here is definitely not a parabola. So let's see here. We got x going from negative 2 to 2 if you look at these values here. So 2 over this way, negative 2 over this way, like that, give or take. Probably close enough. Yeah. And then the y values, where are they going from? About a high of 6 down to a low of negative 10. So up 6 this way. That's about right. And then negative 10 down this way. I probably have to go down a little further like that. I don't know. Let's see. 2, 3, 6, 7, 8, 9, 10. Of course, I'm just winging it here on this blank space. It's best to do this with graph paper to keep your tick marks and even your axes a little more regular. But this will work for the purpose of applying this function. So let's go ahead and plot these points. And shouldn't be too hard to do. Where is 0, negative 2 at? Well, 0, negative 2, x is 0, y is negative 2. It's going to put it right about there. Hard to see that there. There it is. Okay. And then you got 1, negative 1, so it's over 1, down 1 right here. And then 2, 6, it's going to be up here. What about negative 1, negative 3? That would be right about here somewhere. And then finally negative 2, negative 10 way down here. Give or take. Alright. Okay, so you can see basically you got these points kind of giving you a shape like this. Just imagine a smooth flowing curve connecting all the dots like that. And you don't have to work too hard at it. Just sort of try to get in there. And make it smooth. Go through the dots like this, more or less. And come down. Alright, good enough, good enough. This is an example of a cubic function. Now you can make your cubics do a little more twisting than this. This would be a pretty simple version. Sometimes they'll wiggle around a little more in the middle like that. You could also make them go the other way so they can look like this, or maybe wiggle around a little more in the middle like that. So these are just different examples of cubic. But that's basically what a cubic function looks like. It does not turn around like a parabola does. It may do a little bit of wiggling there in the middle, but eventually it will point up one direction, down the other, up one direction, down the other. And there's a lot more to say about cubics and what we call polynomial functions in general. We'll have to, again, leave that to another course. But as you can see, the idea of plotting points here is not that difficult to do. And drawing the graph by just connecting the dots, I get a nice picture there. The main thing is just try to keep your points as simple as possible so that you're not having to work harder than necessary. Let's do one more. I want to do a radical function with you. Something involving a square root I think will be perhaps instructive. Let's go ahead and do that. Erase this here. Alright, we got that. Let's get ourselves centered here. This thing's always getting out of kilter every time I erase that board. Alright, so our other example I want to look at is this square root function here. G of x equals the 2 minus the square root of x plus 4. There we go. Give you a chance to look at what a radical function looks like. Alright, so again we want to pick off some points to plot. Keep it simple. And one of the things you want to remember about a function involving a square root, or really any even root, is the possibility that if you plug in certain values for x, the inside of the radical might become negative. And then what does that lead to? That leads to having complex numbers. And you really don't want to go there because you can't plot complex numbers. We're going to draw the real plane here in a moment. You can't plot those complex numbers because it's all real value. So you don't want to get any complex numbers. That's a complete waste of your time. Avoid doing that. So as a general idea or principle, when you go into a radical function, a square root function like we have here, you want to make sure the inside of the square root does not become negative. So you stare at that for a moment and you ask yourself, all right, how low can we go with x? How small can x be before you get into trouble? That is, before it turns into a negative number inside the radical and you have a complex value in your hands. Well, if you stare at that for a moment, you'll realize the lowest that x can be, the smallest that x can be, is negative 4. All right? You go any lower than negative 4, like if you try to put negative 5 in there, or even negative, say, 4.1, that's going to give you a negative value inside the square root. And that's no good because it leads to a complex number and you can't plot that. All right, so no smaller than negative 4. All right, so let's put negative 4 in. That should be pretty easy to do. Negative 4 plus 4 is 0. What's the square root of 0? 0. 2 minus 0 is 2. That was easy. How about negative 3? Let's try that. What's negative 3 plus 4? 1. And then square root of 1 is 1. 2 minus 1 is 1. So far, so good. Now here is where you're going to get into a little issue. Suppose I tried to put in, say, something like this. Negative 2. Now, if you do this, you'll get negative 2 plus 4, which is 2, and then you have the square root of 2. Now, what is the square root of 2? Well, it's not a friendly number, is it? You could take out your calculator and you could fiddle with that and have some type of decimal here for the y value. You could do all that if you want to, and there's nothing wrong with that. But to me, that's more trouble than it's worth, so I ain't going to bother to do that. I'm going to try to keep this as simple as possible. I'm going to avoid putting numbers in there for x that make the square root nasty. I want to keep the square root simple. Something nice, like square root of 9, square root of 4, square root of 16, something I can do easily. So as I think about this, I'm going up. So negative 4, negative 3, what's the next value up from negative 3 that's going to keep this square root simple? Well, it's not going to be negative 1, because negative 1 plus 4 is 3. That's no good. What's the next number above negative 1? 0. Will that work? Yeah, because 0 plus 4 is 4, and that's not bad. So put a 0 in there. 0 plus 4 is 4. Square root of 4 is 2. And then 2 minus 2 is 0 for the y value. Good. All right, let's keep going up from the 0. Think about various values to plug in here for x. What's the next number above 0 that we can plug in for x? Then again, we'll keep the square root nice and friendly. Don't want it to be nasty. You want it to be nice and friendly. So 1 won't work because 1 plus 4 is 5. 2 plus 4 is 6. 3 plus 4 is 7. 4 plus 4 is 8. 5 plus 4, bingo. That's a 9, isn't it? So put a 5 in there because 5 plus 4 is 9. Square root of 9 is nice and easy. It's a 3. And then 2 minus that 3 will give you a negative 1. Let's do maybe one more. Keep going up from the 5. You'll have to go all the way up to what? You'll have to go all the way up to 12, won't you? Because 12 plus 4 ends up being 16, doesn't it? And then square root of 16 is nice. So you have square root of 16 here, which is 4. 2 minus 4 is negative 2. There we go. That should be enough. Usually 5 or 6 points is plenty to get a pretty good idea what the graph looks like. So we'll draw it over here. There we go. Let's see what this looks like. The x values basically go from a low of -4 to a high value of 12, so -4 to 12. And I don't even know if I can get the 12 on there exactly. Let's try it here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There we go. So I guess I could get it on there. And then the y values, they don't go nearly as far. Just basically a high to 2 down to low -2, so they're not going as far. By the way, I recommend trying to keep your, what they call tick marks here, keep the equal scale on the axes. What generally tends to happen is sometimes one axis you seem like you space out the tick marks more than the other. I have a tendency to make the y tick marks here farther apart than the x's because I got so many x's to cram in there. But try to keep them same scale, same spacing as much as possible. That'll help make your graph look a little more like it should. As I mentioned earlier, graph paper is really the best way to do this stuff because that'll help you keep everything nice and regular. At any rate, let's go ahead and plot some points here then. We've got -4, 2 as our first point, so -4, 2 is right about here. And then we have -3, 1 right about there. And you got 0, 0 right there at the origin. You can see that. There we go. Then we got 5, -1, so it's out here, 5, -1. And then finally 12, -2 way down here. Alright, so you can kind of see there's a pattern right there. Smooth flowing pattern. Always with these dots you're trying to do a smooth flowing pattern to connect them as much as possible. The one exception you'll see in the notes there on page 353 is the absolute value function. It has a sharp point. I won't bother graphing that on this video, but you can just look at the notes and see that there. Once you see a couple of these guys, I think you get the hang of it. Anyway, let's go ahead and just connect the dots here as smoothly as we can. Just kind of start here and wheel our way down, down, down. Just kind of keeps on going down like that forever. There you go. And that's what the graph of a square root function looks like. Basically, square root functions start someplace and then they just kind of go off one direction like this. Or they could start that way and go on a sort of upward climb. They could also go the other direction. So you could start over here and maybe go down this way, the other direction. It's possible for them to do that. Or to kind of go up that way. So these are the four basic patterns that you see in square root functions. And one of the things I would like to point out is you'd say, well, this is kind of curious. Why is it that it seems to basically stop right here when x is -4? Why don't I see the graph sitting on this side? I only see it on one side. And that's the way all these square root functions are. They just sort of start someplace and they go off one direction only. They do not show up on the other side. Or over here, they'd start up here, let's say, and go to the left, but you would not see it over to the right. So the question I want to ask you at the end of this video is, why? Why does it do that? Why does it only go in one direction, it seems? You know, it's going to go forever in this direction, out this way. But why does it stop right here like it's hitting a brick wall, so to speak? Well, remember what happened up here when we were talking about getting this -4 in the first place? Why was -4 sort of the smallest value for x that we're going to go to and not any past that? Because if you go beyond that, you get a negative number inside the square root, and that leads to complex solutions. So really what's happening here is the function is going into another dimension. It's leaving the real plane into the complex plane. You can't really graph that. It requires 4 dimensions to see that, and there's no way to do that. So all we can see is it just disappears from this vantage point. And that's the nature of even root functions, square roots, fourth roots, any type of even root function. You'll tend to see that behavior where it just disappears because it's going into a higher dimensional plane, the complex plane. And that's how you graph functions by plotting points. Not too difficult, and again, it's not on a test, it's all optional. Play with them if you like, ignore them if you want. That homework is just extra credit points anyhow, so you don't have to worry about it. And in fact, I'm telling you that if you don't like to do this stuff, the only graphing that's going to be on the test is the parabolas at the beginning. Any other type of graphing you see later on, it's optional. I encourage you to have fun with it if you feel like it, want to explore it, but don't feel that you have to know it for the test.